Okay, so welcome everyone. Nice to see you here. My name is Mark. I think a lot of you guys already know me from previous courses or maybe from the work groups. But I will be your teacher today for this course. What we're going to discuss is week 1. So we're going to discuss the Hirshleifer model. Let me show you here the Hirshleifer model. And then the second chapter, which is about the basic concepts in finance. And I also sent you the summary about week 1 in the WhatsApp group. And after today, I'm 100% certain that you know all the exam questions about it. So how we're going to start is I'm going to tell you some theory so that you really understand the graphs and the formulas and what the model represents. And then after the theory, I will show you some examples. I will take some easy examples from the workbook. And then we top it off with 2 old exam questions about the Hirshleifer model. And if you want, we can also discuss some of your quiz questions or other questions you encountered that you find difficult. And then at last, we will do the basic concepts in finance. And you will see that that chapter is actually really easy. You just need to memorize a lot of formulas, but then it's just a matter of filling them in. It's not that difficult. And that's the schedule for today. I'm recording this session. So it's good that you don't turn on your video, because then you would be in the screen and then people might see it later. Also be aware that I'm recording it, so your voice might be on the video. But to be honest, I prefer you guys to answer the questions with your audio. But if you don't want that, that's also fine. Then you can send me your answer with the chat or something. But I will ask you guys a lot of questions. That's my style of teaching, especially when I'm doing it via Zoom, because I cannot see your face. I cannot see if you understand it. So therefore, I'm also asking a lot of easy questions just to see if you guys still follow me. Okay, so let's start then. So week 1, the first thing you need to learn is about finding the present value. And to understand what a present value is, I'm going to show you a really easy example on the whiteboard. So the key about the time value of money is that you have 2 times. So you have T0 and T1. And you can choose between cash flow A, which gives you 100 euro today, or you can choose for cash flow B, which gives you 109 euro next year. And let's say the interest rate is equal to 10%. Nasser, can I ask you a question? What would you choose? Would you go for the 100 euro today, or would you go for the 109 euro next year? What would you choose?
100 euro today.
Yeah, why would you go for the 100 euro today?
I don't know. It's more applicable, I think.
I would also go for the 100 euro, but the most interesting thing is, why would you do it, right? And I think you would go for the 100 euro because if you put it on your bank account, how much would it be worth next year, Nasser?
Yeah, it would be 110.
Exactly. And that's better than this 109, right? And that what we now did is we converted this 100 euro into the future. So we calculated the future value of that 100 euro. And by doing that, we represent the 2 cash flows in the same time period. And only then you can compare the 2. And then you see, all right, this 100 today is better than 109 next year. So that's the future value. So you do times 1 plus the interest rate times. That's the future value. But you could also do the opposite of multiplication. What is the opposite of multiplication? That is division, right? So you could also divide this 109 by 1 plus the r. And then you get the present value of the 109. And what would be the present value of 109? Could you calculate it for me? Maybe somebody else could also do it. You could just take your calculator. So 109 divided by 1.1. What do you guys get? You can just say it or type it in the chat if you know it. I truly don't know it. I don't have a calculator with me, but you should have one. I think, yes, you get 99.01 or something like that, I suppose. Okay, and that's so could you give it in 2 extra decimals, Timmy? Because in the exam you should also round it with more decimals than 99. I think you get something like,
then 0909 and so on.
yes, exactly. Okay, and now you can also see that this cash flow A has a higher present value than cash flow B, and therefore it's better. And that's the key thing, that €1 today is better than €1 next year. Why? Because if you get it today, you get interest on it. Okay, so that's the time value of money. €1 today is better than €1 next year. And therefore we have to do the present value. I see something in the chat. Yes. Example 2. We now have a 3 time, so 2 periods, 3 different times. You have the cash flows of A, which is, let's say, €290 today. Or you can go for the cash flows from B. Sorry, I have to move this to the left. So today, I'm sorry, 290 at moment 0. So today. Or you can have €100 next year, plus €100 the year after that, plus €100 in the year after that. And let's say that the interest rate is 10%. Can I just say, oh, this is better because this is €300 and that is 290. So therefore the cash flows from B are better. Can I say that? What do you guys think? No, right? Because then you are not taking into account the time value of money. €100 today is better than €100 next year. So instead, we need to calculate the present value. And how do we do it for multiple periods? The present value for B is 100. And then this 100 needs to be shifted 1 year back. So this one, I only divide 1 time by the 1.1. But this €100 here needs to be shifted back 2 periods. So that one will be divided by 1.1 squared. And then this one, 3 periods, 1, 2, 3. So I do 1.1 cubed. Could somebody plug this into his calculator so that we can see what is better? 290 today or €100 next year, 100 after that, and 100 after that? Which of the 2 is better? So you can send your answer in the chat if you have it, or you can just say it in the microphone. $248.69. Very good. Did everybody have that? Thank you. And then Timmy said, so indeed, A is better than the cash flows from B because this 290 is more than that. So this was just a simple introduction of how you calculate present values. Sometimes you can also have that you have to do some sort of investment to gain those cash flows. That's what you're seeing here. The net present value is the present value minus the investment. So maybe you have to invest €50, and then after that you get that €100 each year. Then that €50 would be your investment, and then the present value is just the present value we just calculated. Okay. So also that's an important formula. Yeah, I can show you one quick example. It's just an introduction. So let's say that the cash flows are like this. I have to invest 50 euro, but then after that I get 100 euro, 100 euro, 100 euro. And then the question is calculate the net present value. What you do is you do 50, that's the investment, so minus the investment, plus the present value. And we already calculated the present value for those three. We saw in the previous example that it was 248.69. And that's basically how you calculate the present value, the net present value. So I'm really bad in arithmetic, but I think you get something like 192 or 91. Is that correct? Man, I'm really bad in this.
198.
98. 98, of course. Man, that was really stupid. Okay, forget about that. And then the thing with the net present value is that if the thing is positive, then it's a good investment. If the net present value is negative, then it's a bad investment. Then you shouldn't make the investment. Okay. That's just an introduction. Okay. So now, here are some examples. I basically did them already on the whiteboard. Now I'm going to tell you about the Hirshleifer model. Okay, the Hirshleifer model is you always on the exam get 2 questions about the Hirshleifer model. And the idea is that you first need to know what all the formulas, what all the letters are standing for. So that's just a bit theoretical. I will now sum them up so that you just have heard them once. Then I show you how the model is built. Then I show you some examples. And then eventually we're going to do some action questions. So first, I would just give you an introduction of how all the variables are, what they represent. I don't expect you to remember them straight away, but you will see that when we are going to practice, then you will easily recognize what they mean. Okay, so I will also get my summary on my mobile phone. I am, by the way, a bit sick, so my voice is a bit less good than it normally is, just so you know. That's also one of the reasons why I did this trial session online. Okay. So the model can be separated into 3 different categories. You can have the model without a financial market and without a real market. You can have the model without a with a financial market and without a real market. And you can have it with financial market and with a real market. And I'm going to show you what that means in a second. Okay. So the basic idea is that you only have 2 periods. Sorry, you have only 1 period and 2 moments in time. So you have the today, that is t is 0, and you have t is 1. And you will get a particular cash flow today, and that's called the CF0. Let's say that's 100 euro. And you have a particular cash flow next year, the CF1. And let's say that's also 100 euro. And we want to draw a line with all the possible consumption bundles. And that's what we're going to draw. What you then get is, I have to, by the way, shift this a bit to the right then. Is you can basically say that if you don't have a financial market, so without financial market, that means there's no bank. So there's no bank that where you can borrow money or where you can lend money. And there's also no interest rate because of that. So a financial market means that there's a bank. And now we assume that there's no bank, there's no financial market. So there's no interest rate that I can use to borrow or to lend money. Furthermore, we, for simplicity, assume also that there's no real market. And what do we mean with a real market? A real market means that you can do an investment and then you can get some present value because of that. And that makes you richer. So a real market means that you can do an investment to get a present value in return. Okay. So we want to draw all the possible consumption bundles. And one possible consumption bundle is that I just spend what I get. So I get 100 euro today. I consume 100 euro today. I get 100 euro next year. I consume 100 euro next year. So those are called the C1. That's how much I consume today. And the C1. That's how much I consume next year. That's one possible consumption bundle. But maybe you want to go one step to the left. And if I go one step to the left, I consume €1 less. So I only consume 99 euro. But that means that I can consume 101 euro in the year after that. So the slope of this line would just be 1. And then my question to you guys is, what if I take it to the extreme? What if I save all the money I have today? How much can I consume next year? What's the maximum amount I can consume? Does anyone have an idea? Yes, very good. 200 euro indeed. Okay, that's the model without financial and without a real market. Now we go to the next one. That's when you introduce a financial market. How does it look then? So what if you have a financial market and without a real market? Then we can basically make the same sketch. So you have some t is 0, t is 1. And we again say that CF0 is 100. And the CF1 is also 100. And the R is 10%. So notice the interesting thing. If I now save 1 euro, so I only spend 99 euros today, how much do I get next year in return for that 1 euro I save? In the previous example, without the financial market, it was 1 euro. If I save 1 euro, my consumption increases by 1 euro. But what happens now if I save 1 euro? By how much will my consumption increase next year? By how much will my consumption increase? Do you have an idea, Sharaf? Yes, by 1.1 euro. So you save 1 euro, then you get 1.1 euro in return. And now if I take that to the extreme, what is the maximum amount I can consume next year? So I save this whole 100 euro. Then I get 10% interest on that. And on top of that, I have an income of 100 euro. How much what is the number that should be located here? $220, very good. And we call this the B. So the B is 220. And here you get your first formula you have to know. So OB, which is the, in Dutch, the in English, it's the origin. So this is O. And then for the area between O and B is 220. That's the OB. And the formula for that is the CF0 times 1 plus R plus CF1. And that's how you got the 220 here. So you did 100 times 1 plus R plus this 100 here. That's how you get the 220. Very good. Oh, sorry, it's 210. Sorry, you gave it to me and I didn't think. It's indeed 210. Because 100 times 1.1 is 110, plus this 100 is 210. So very important, 210, not 220. Okay. Notice that here we are saving. So you can say here we are saving at this part of the line. And notice that saving is basically the same as lending. So if you're saving at the bank, you're basically lending money to the bank. Okay. However, here it is also possible to lend. And then I move into this direction. So let's have a look. And at this part of the line, you will have A. And A is the maximum amount I can lend. So if I go one step to the right, I basically borrow €1 extra so that I can consume 101 euro. But that means that I can consume less in the future. So if you now borrow €1, you consume €1 extra today, but you can consume 1 plus or less in the future. Okay. And the question is now, what is the maximum amount I can consume today? So what is the OA, the origin all the way up to the A? And the formula is, that's just the present value of your income. So the maximum amount you can consume today is the present value of your income. So you do CF0, that's already in terms of today, so we don't need to discount the CF0, plus CF1 divided by 1 plus R. And could somebody fill that in and see what we get? You can just also say it with your microphone, it doesn't matter. Maybe you know it, Floris.
$200.
191. Could you give 2 extra decimals, Zoo? So it's 100 plus 100 divided by 1.1. So could you give it with 2 extra decimals? Yeah, there it is. Yeah, very good. 190.9. Very good. So the maximum amount we can consume today is 190.9. So now I hope you know what the CF stands for, the CF0, the CF1. I hope you know what the A and the B stand for. And notice this really important relationship, because the slope of this line is 1 plus R. It means that if you multiply A by 1 plus R, you get the B, because the slope is 1 plus R. So you can take your calculator, and you can say OA times 1 plus R. You can try it. That should give you the OB. You can check. Take your time to check it. 190.9 times 1 plus R is this 210. Do you guys get it? Okay. So now we go to the final model. Remember this A, which represents the maximum amount we can consume if there's no real market. Now we go to the last model, and that's the model they will use probably on the exam questions. And that is with a financial market. So we have a bank where we can borrow and where we can lend, and with a real market. And again, a real market means that we can do some investment. And that investment will give us a return. Okay. So we are going to sketch the same graph. And T is 1, T is 0. And now I use the point A that we already found as my starting point. And then here I'm going to draw a pretty strange line, and that's this line here. Okay. And we call this line D. Line D is not that important, but just so that you know what are we actually drawing. How it works is as follows. Line D. Oh, by the way, let me mute my WhatsApp. Maybe that helps a bit more so that you guys don't get confused about it. So I disabled the sound. Okay. So what you're seeing here is line D. And what line D represents is the proceeds of your investment. So you're going to make an investment, and then you get some money in return for that. And that will be line D. So let me show you. If I go one step to the left, I invest €1. You will see that for my first investment, I get a huge proceeds of investment. I get a lot of it for it in return. So for example, I get €10 for that first euro I invest. But then if I do my second euro as an investment, I get less extra in return. Now I will only get, for example, €4 in return. Then I do another investment of €1. And then I only get €2 in return. And what you will see is that there's a diminishing marginal return on investment, a diminishing marginal return in investment. And what does it mean? It means that the first euro I put in gives me more in return than the second or the third euro I invest. And now the question is, how much should I go to the left? How much should I invest here? And the answer is, well, that depends on the interest rate. Well, the question from Wisken the Maniac is, what is the intuition behind that? The intuition is that you will first do your best investments. Yeah, the intuition of the diminishing marginal return on investment. The intuition is that you will first do your best investment available. And after you did that, you will do your second best investment. And then you did that, you will do your third best investment. All the way up until you do the really shitty investments, basically. Okay. So the question is, how far should I go to the left? How much should I invest? And the answer is, well, that depends on the interest rate. We will go to the left as long as the return on our investment is higher than the interest rate. Because eventually the interest rate is bigger than the return on the investment. And then you're better off by putting your money in the bank rather than investing it. So we can draw a line like this. And this line will have the slope 1 plus R. So from this point here, you can better put your additional euro on the bank than that you are going to invest it in the market, because the interest rate on the bank will be higher than the return on that additional euro. And this point we call point E, and point E all the way to A. So this point here, that's your optimal investment. So let's say that this area is 100, then you should invest 100 euro. Okay. Then here, you will have point F, and point F is the proceeds of that optimal investment. So that is, for example, 200 or something. Then if you make the optimal decision, you will invest, for example, 100, but then your return on that investment will be 200 euro. And that is the OF. So the origin all the way up to F, OF, that is the proceeds of your optimal investment, a very important variable. So now if we go back to the slide, I think you already know a lot of variables. You can check for yourself. You should know the CF0, the income at today, CF1, the income next year, OA, which is the maximum consumption without a real market, OB, maximum consumption without a real market, but then next year. OG, we didn't discuss. OH, we didn't discuss. OF, we already did discuss. That's the proceeds of your investment that we just saw, and the C0 and the C1. So then the only question is, what is then the OG and the OH? So the idea is that because we did this investment, we got richer. You will see that you will only do this investment if it makes you richer. So therefore, the net present value is positive. And what happens is we first had this A here. That was our maximum consumption today without a real market. And where this intersection is, we call that the G. And that is the maximum consumption with a real market. So OG is the maximum consumption today with a real market. And then you will have the H as this thing here. That is the maximum consumption next year with a real market. Okay. And this is pretty interesting. By how much did you get richer? The NPV. So OE is your investment. OF is the proceeds of your investment. And AG, AG is the net present value. And now I have a question for you guys. We know that the net present value is the minus the investment plus the present value. Do you guys have an idea what the EG is then? So to be more precise, this here is the investment. This here is the net present value. What is the red plus the blue line? Do you guys have an idea? So red plus blue. Does anyone know it? I will tell it. It is the present value. So if you have EG, that area, that's the present value. And then if you subtract the red area, the investment, then you're left with the net present value. So this total area here, minus the red area, minus the investment, is the blue area, the net present value. So you can write down in your summary or in your notes, EG is the present value. Okay. Yes, very good. Okay. So to summarize, I now added back the A and the B line. And then this is the final model that you will work with during the course. So it starts really theoretical, but you will see that from now on, we will do a lot of exercise for the rest of the session. Okay, but now you know all the variables. So OG is the maximum consumption today with the real market. One last question. If I do G times 1 plus R, what do I get? Does anyone know? Remember that the slope of this line is 1 plus R. Yes, you get the OH. And maybe an even more difficult question. AG, so this area, AG, is the NPV. If I do that times 1 plus R, which area do I get? The AG is the NPV. And if I do that times 1 plus R, what do I get? BH, not DH, but BH. So I will also send it in the chat, BH. So you get from this point all the way up. So you can write down in your notes, BH, that is the NPV times 1 plus R. So AG is the NPV, but BH is NPV times 1 plus R. Okay. Then here, I taught this course for like 7 years or something. And what I did is each time I needed a formula, I included it in this formula sheet for the Hirshleifer model. And with those formulas for the Hirshleifer, you can do all the old axiom questions that you have. So I will guide you through it. Because I'm now working with a free Zoom link, I cannot use the annotation from Zoom, but I will use it from PowerPoint itself. This first formula is just the NPV formula. It's the present value minus the investment. And then the present value is found using this fraction. It's the proceeds of your investment, OF, divided by 1 plus R. That's how you get the present value. Then here, the OA we already saw, that is the present value of your cash flow. If you have the OG, so here you have the OG, then you do basically the same as for the OA. You take the present value of your cash flows, but you also add the net present value. So the OG is always bigger than the OA because the NPV is positive. And the OG is basically this formula here, basically is the present value of your income. And the idea is that you will spend all your income during your lifetime. You will not leave any money on the table. So we can say that in equilibrium, your present value of your income will be equal to the present value of your consumption. So therefore, there are two formulas here to get the OG, because we know that the present value of all your income, including the NPV, is equal to the present value of your consumption. Then this third formula is just a strange formula. You will not use that often. It's the OE plus the OF divided by 1 plus R. It doesn't have a really good interpretation. Obviously, this is just your present value here, but the OE doesn't have a clear interpretation. And then lastly, remember the relationship. OG times 1 plus R is the OH, and that means that OH divided by 1 plus R is the OG, and the same holds for A and B. And those are all the formulas you need for the Hirshleifer model. And then here, this is the most important thing for today. Here I have a really nice method. With this method, and that's basically the key takeaway of today, you can really easily solve the Hirshleifer model. So that's basically what I'm going to show you, how to work with this method. You will really like it. To practice with it, I'm going to show you in a second 2 workgroup exercises. And then afterwards, I will make it a bit more complicated with some axiom questions. And then you will really understand this method and you will find it really helpful, I promise you. Okay, so what is the idea about the Hirshleifer model and in finance in general? With finance, you always get a really big exam question with a lot of numbers. And you have to work really structured so that you know all the numbers. So always, if you get a question, write down all the variables they provide you. And if you're doing that, you can just as well write them down into this table. So what I did in this table for the Hirshleifer, I used the fact that the inflows will equal the outflows. So what are the inflows that you have? The CF0, the borrowings, those are the inflows in T0. And what are the outflows? Well, you can consume something, you can invest, or you can save. Then in T1, you basically have the same ID. You have some inflows, which is the cash flow 1, the proceeds from your investment, and then the principal plus interest. And then you get some outflows, which is the C1, the installment plus interest rate, and those are the outflows. And what is really important is that you have to, and maybe you want to even write this down, you're either borrowing or you're saving. You can never do both at the same time. So if borrowing is a positive value here, so let's say it's 100, then you already know that the saving has to be 0 because you're always doing one of the two. And the other way around. So if you know that savings is positive, then you know that borrowing is 0. Another thing you need to know is that the inflows will always equal the outflows. You can never spend more money than comes in. This really always holds that the inflows will be equal to the outflows. Okay. So what I now need is I need one student to make a picture about the most easiest exercise, just to get familiar with this method. So Timmy, would you like to make a picture of the first question from chapter 1? And could you send that picture in the WhatsApp group?
Sure.
So you start always by writing down the model. So you have your CF0, you have your borrowing, you have your C0, your investment, and your saving. That is what you have at TS0. And then at TS1, you have the same. You have CF1. You have the OF. And what was the OF again, guys? OF was the proceed of your investment, right? How you made an investment, how much do you get from that in return? And if you save this here, you get your saving back, including some interest, right? And then you have the C1. And you have, if you borrowed here, you have to pay that back, including the interest. So that's a cash outflow, borrowing. Okay. So here comes the good part. I need one of you guys to help me with this. Davide, would you like to help me with this question? Would you read the question for me? And then we will fill it in together. Davide, are you there? Okay. Then I will ask Ayo. Ayo, are you there?
Yeah, I'm here.
Okay. Would you like to read the question for me? And then we fill in all the numbers.
So CF0 is 400.
Yes, very good.
CF1 is 420.
Yes.
Yeah, investment is 120 at T0.
Mm-hmm.
The proceeding of the investment is 184.
Yes.
Consumption at T0 is 350.
Yes.
And the interest is 15%.
Yes, we will write it down here. Okay. So with the red numbers, I fill in all the question. If you see the color red, it means that I got the number out of the question. You could just read it from the question. Now I will start writing with the blue marker. And now we use the inflow equals outflow method to get the other numbers. Okay, so maybe you can help me, Eyal. My cash inflow is 400, but here I spent 470. So I came up 70 short. What does that imply about the amount I borrowed?
You borrow 70.
Yeah, perfect. And that means I didn't save, because if you borrow, you couldn't save. So I got those blue numbers because I know that the two need to balance. I get a 470 cash inflow and a 470 cash outflow. So is it clear how I got this 70 here? Is that clear for everybody here? Okay. Now I want to calculate how much do I have to pay back. So I borrowed 70 and the interest rate is 15%. How much should I pay back?
It's 80.
So you do. Oh, and by the way, sorry, here should be a 1 plus R added. Yes?
80.5.
80.5. Very good. Is that clear for everyone? So we did 70 times 1 plus R. I didn't save. So do I have any savings here? No, right? So I put that to a 0. And now what I will do, I want to find this last value. How would you do that, Eyal? You know that the inflows should be equal to the outflows.
So I'll sum up what I get. So 400,
Yes.
184, and I'll deduct what I need to pay back.
Yes, perfect. So you take your calculator, you add those numbers together, and then you do minus the 80.5 to get this number.
Yeah, it's
And if you do it,
523.5.
sorry, what did you say? 500?
23.5.
Yes, perfect. Okay. And now we have all the numbers. So now we can start looking at the question. Is it clear how I got those blue numbers? Are there any questions about that? No questions? Okay, then we are going to look at question A. So Timmy sent the question in the WhatsApp group. So we already know that A is true or false. A is? He says that the consumption is 513.5. Is that correct?
A and B are both false.
Yes, A and B are both false. Okay. Then we go to C. Do you have an idea how I can find C? So if you look in the formula sheet, do you remember that OH is the OG times 1 plus R? Do you remember that? OH is OG times 1 plus R. And we also know that the OG is the C0 plus C1 times 1 plus R, right? So maybe I can write it down here. So that's the OG here, C0 plus C1 divided by 1 plus R. If I multiply that by 1 plus R, I get the OH. So I know that the OH is C1, C0 times 1 plus R plus C1. Do you agree that this is the formula for the OH? So it's the OG times 1 plus R. So it's the formula I just showed you times 1 plus R. That's the OH. Okay. What is the C0? What is the C0?
It's 350 times 1.15, which is 402.5.
Okay.
And then if you add 523.5, then you just get 926.
Yes, perfect. So that means that C is correct or incorrect. So C is false, right? And then D is correct, right? There they say OH is 926. Perfect, Eyal. Thank you very much. I see something in the chat. Why are A and B false? Because the consumption in year one is 523.5, while in question A and B, they say something different. So therefore, A and B is false. Does that make sense? Okay. Any other questions? Any other questions? No? Okay, Timmy, could you make also a picture about question 1.2? So question 1.2. And then I'm going to ask Neil to help me. So after Timmy sent a picture of question 1.2, I'm going to ask Neil to help me if you're there.
Question 2. Oh, okay.
Yeah, so chapter 1 and then question 2. There you go. Okay, Neil, are you there? Yushi, are you there? Yushi? Lieselot, are you there?
Yes, I am.
Great. Would you like to help me with this question? So we had the CF0, right?
Mm-hmm. Yeah, that's 80.
We had.
Oh.
Let's first write down the tape. But we have borrowing, and then we have the CF1. Sorry, we have the C0. I mean, what do we also have as the outflows?
Savings and investments.
Investment and savings, very good. And then for the TS1, sorry, for the TS1, what do we there have as the inflows?
CF1 and proceeds from investments.
Yes, that's the OF, receipts investment, and the savings times 1 plus R. And then here we have the C1 and the borrowing. Times 1 plus R. Okay. Now, could you read the question and tell me what are those variables are?
Okay, first of all, CF0 is 80.
Yes.
CF1 is 150.
Mm-hmm.
Investment base 88, so the OF is 88.
Yes, very good. I think you missed one of them, but maybe you missed one variable.
I see investment is 60. I read over it.
Yes, no problem.
He borrows at TS0, he borrows 50.
Mm-hmm.
And he pays interest at TS1 for 5. So
yes, that doesn't fit into the model. So we just write down interest is €5 below the model. So just a note. Okay. Now we're going to look. I'm going to get my blue marker. Can we fill in the missing value? So first of all, borrowing is 50. What do I now know about the savings?
That the savings is 0.
Yes, because you're either borrowing or you're saving. You cannot do both at the same time. Okay. I have an income of 130, but I'm only spending 60 so far. So what do I know about the C0?
That must be 70.
Yes, very good. So I can fill in 70.
Mhm.
Notice that I borrowed 50 euro and I had to pay 5 euro interest. What is then the interest rate?
10%.
Yes, everybody understands that? And then how much do I have to pay back? If I borrow 50, how much do I have to pay back?
5.
55. My savings is 0. So what do I put here?
Also 0.
Yes. And then lastly, could you calculate the C1 for me?
Yes, that is 1 minute. $183.
183. Okay. Perfect. Is this clear for everyone so far? So that's basically the key insight of today, how you can work with this model. Now we're going to look at the question. So we have question A. What do they ask at question A?
If the consumption equals 236.
No, that's not correct.
Mhm.
B.
That one is correct, I think.
Yes, it's indeed 183. Then we also know that C is false. And then D, OG. What was the formula for OG that we can use?
C0 plus C1 divided by 1 plus R.
Yes. Well, C0 is 70, right?
Mhm.
And then 183 divided by 1.1. What do we get?
Around 166.
166. Point, could you give me 2 more decimals?
36. 166.36.
All right. So then D is also not correct, right? Okay. That's it. Thank you very much, Lieslo. So is this balancing method clear for you guys? Are there no questions so far? Okay. Now I'm going to make it a bit more complicated. What you will see is that during the real action questions, you cannot easily balance the 2 inflows and the outflows. You will have that sometimes you have 2 or more unknown variables. That means that the balancing doesn't work yet. And if that happens, you're going to look at this formula sheet, and then you're going to look which of those formulas has 1 unknown variable. Because if it has 1 unknown variable, you can use this formula. So again, with more complicated questions, the balancing method, you will get stuck because you have 2 or more unknown variables that you cannot balance. In that case, you go to one of those formulas and you look which of them only has 1 unknown variable. And then you can use that to win an extra variable. And we're going to practice with that with this action question. So what I do is I show you this action question. I will make a screenshot of it, and then I put it in the WhatsApp group. So give me 1 second. And you can look at it with your mobile phone. And now we're going to have a look. Okay. Brian, are you there? Do you want to help me with this action question? Sharaf, would you like to help me with this action question? Leo, would you like to help me again?
Yeah, of course.
Okay. Oh, I see. Briar's. All right, no problem, Briar. Perfect. So, Aya, we start by writing down the table again. So, what were the variables from the table?
The cash flow,
Yes.
the investment.
Not yet. I first write down the inflows. So we had the borrowing. That's also an inflow, right?
Yeah.
And then you have the consumption 0 and the investment, like you said. And then at last you have the
Savings.
saving, which is the same as lending. And then if we look at TS1, what are then the inflows?
So CF1,
CF1.
Borrowing.
No.
I'm sorry, the proceedings.
Yes, the OF.
Yeah. And
then the saving
proceeding.
times 1 plus R. And what are the outflows?
C1. And then to pay back for borrowing.
Yes, to pay back for borrowing. Perfect. Okay. So we look at the exam question. And then we're going to fill in the information. So I call it exam question 1. You can see it in the WhatsApp group. Okay. So could you help me to fill it in? And I use the black marker again to fill everything in.
Yeah. So CF0 is 50.
Yes.
CF1 is 51.
Perfect.
The OF is 102. C0 is 102. I'm sorry.
Yes.
C is 102.
Yes, the C1 is 102 indeed. Yes.
And OG is 150.
Yes, that doesn't fit in the model. So I just write it down here below, right? OG is 150. Just a note.
R is 2.
R is 2%. Okay. So we're going to look, can we balance? Well, here in the first one, we cannot balance yet, right? Because there's only one known variable. But can we balance it in year 1? So we have an inflow of 153.
Yeah, we can say that OH is 150 times 1.02.
One second. My question was if we can know this value here.
Oh yeah. So 51 plus 102 minus 102. That is 51 basically.
Yeah, of course. And then if I borrowed probably. So did I save?
Yeah, you did save.
I didn't, right? Because I borrowed. So do you understand how I got those blue numbers here?
No, actually, because if you earned 153 and you just spent 102, why don't you save the money?
So we are now in next year, right? So what I had an income of 153. I only consumed 102. And why did I consume so little? Because I needed 51 euro to pay back the debt that I had. Because I borrowed in the previous period.
Yeah.
Yes. So I paid back 51 euro. Okay. Didn't have any savings. So that's how you get the blue numbers, by balancing the inflows and the outflows.
Yeah.
Now we can maybe calculate this number.
Yeah, you can discount it with the interest of 1.02, so you get 50 borrowing.
Yes, 51 divided by 1.02 is 50. Perfect. And since I didn't have any savings, did I save here originally?
No.
No. Okay, so here you have 100. This is 0. But now I have two unknown variables. You see that?
Yeah.
And that's the problem. So here, the balancing doesn't work anymore. So in the previous two cases, we could do the balancing completely to get all the answers. But now we cannot do that anymore. So to tackle this problem, you go to your formula sheet and you look which of those formulas only has one formula. And then on the exam, you don't have a formula sheet, but you have this in your memory, of course. So which of those only has one unknown variable? And I give you a hint. We knew the OG, right? We know that the OG was 150, and we know the C1 and we know the R. Just a hint. So which formula only has one unknown variable?
The fourth formula, so we can do.
I will copy it. So we have OG is C0 plus C1 divided by 1 plus R. OG is
150.
150. C0 is unknown, right?
Yeah.
C1 we
Is
know,
100.
102. And 1 plus R is 1.02.
So C0 is 50.
Yeah, C0 is 50, very good. Because this fraction will be 100. So 150 is something plus 100, then that something needs to be 50, right? Okay. So now we know that the C0 is 50. Okay. Then,
Yeah, then
now are we able to figure out the investment?
we can balance with another 50.
Perfect. We can balance it. Inflows 100. Then here we need a 50 to have an outflow of 100. And then we have the investment. So do you guys like this method here? So it's really structured. You get a nice overview of all the variables you have. And the balancing works really easily. Okay. Then we're going to look at the statements. A, B, C, D. Which statement is false? A, Ronaldo invests 50 euro. Is that true?
Yeah.
Yes. B, the net present value of the investment equals 50. Ooh, we have to calculate that. What was the formula again for the net present value?
So minus the investment.
Minus the investment.
Plus the proceedings discounted by the interest.
Yes. Well, the investment, we just figured that out, is 50, right?
Yeah.
OF is 102. 1 plus R is 1.02. So what is the NPV?
50.
It's 50 positive. Perfect. C. At T0, Ronaldo consumes 50 euro.
Yeah, that's also true.
Yes. D. Ronaldo pays 2 euro interest.
No, he pays only 1.
He pays only 1 because he borrowed 50. He had to pay back 51. That implies he only paid 1 euro interest and not 2 euro interest. Perfect. Thank you very much, AO. Okay. Then, next exercise. So question 2. And here, by the way, I inserted the formulas into the summary. I will copy it and put it in the WhatsApp group. Is there a volunteer that wants to help me with this one here? So normally, to be honest, when I'm not doing it online, I give you guys a few minutes to do it yourself. Would you guys like that? That you first try it yourself and that I discuss it afterwards? No? Okay. Then, Sharaf, would you like to help me with this question? Or you were you said you couldn't chat indeed. Okay. Then I'm going to ask Timmy. Timmy, would you like to help me with this action question?
Sure.
So we go to the whiteboard. And we always start by writing down the inflow and outflows, right? So we can do it really fast. Eventually you memorized it, then it goes really fast. CF0, borrowing, C0, investment, saving, CF1, OF, saving times 1 plus R. And then C1, borrowing, times 1 plus R. So let me know if you wrote this down. And then we start.
So we know that at T0, the cash flow is 100,
Yes.
and at T1 is 105.
Mm-hmm.
The consumption at T0 is 150,
Mm-hmm.
and we know there's an interest of €4 at T1.
So I just make a note, interest is €4. And then he invests.
So he is investing €30 at T0.
Mm-hmm.
And EG is €70, the present value of the
That's the present value, right?
yeah,
And BH,
is €42.
yes. Which was the NPV times 1 plus R. Do you remember that?
No, I do.
Okay. So BH was in the graph the what was it? The AG times 1 plus R. So the AG was the present value. So then BH is the net present value times 1 plus R. So I think I didn't say it correctly. So AG is the net present value. BH is then the net present value times 1 plus R. But it doesn't really matter. Okay. So can we balance this a bit? So I now get my blue marker. So all the black numbers were from the question. Now we're going to figure out the rest. So can we balance something here in the first table? Do you have an idea, Timmy, if I maybe can find this number?
Not really. I'm a bit stuck.
Can somebody help Timmy? So we know that the inflows were 100, but the outflows are 180. So probably I had to borrow something.
80.
Yes. And since I borrowed, I know I didn't save. So what is the saving?
0.
Perfect. So is it clear how I got the blue numbers here?
Yeah.
And the interest is €4. So notice that I borrowed €80 and the interest is €4. So what is the interest rate then?
The interest rate is, just have to divide 4 by 80,
Mhm.
and that's 5%.
Perfect. Is it clear how I got this interest rate for everyone?
Yeah.
Okay, then borrowing is 80. So I borrowed €80. Then how much did I have to pay back? So
I
borrow 80.
To multiply 80 by 1.05, and that's
Yes.
84.
Yes, perfect. Or you could also add this interest to it. Both are fine. Okay. I didn't save anything. So how much savings do I have next year?
0.
Perfect. And here you see the problem again. I have two unknown variables, OF and C1. And we said if you have two or more unknown variables, then you have to look at the formulas again. So just to give you a hint, to get the OF, we could use the formula present value times 1 plus R. Do you remember that? Because the present value was the OF divided by 1 plus R. So to get the OF, you do present value times 1 plus R. That's the reason. Does that make sense?
Yes.
Okay. So could you use that to calculate the OF?
The BH was the present value? Or what was the BH again?
The what? The
The
BH?
BH, the 43.
Oh, you don't have to use this. But it was the net present value times 1 plus R. But we will not use that. So this was irrelevant, but it is the net present value times 1 plus R.
Okay, thanks. So the present value is 70, and then I multiply it with 1 plus R,
Mm-hmm.
and that's 70 plus, and that's 73.5.
That's perfect. Now, last question. What is the C1?
My consumption is T1. I have a cash flow 105 at T1. And I borrowed.
So what you do, you sum all those numbers together, right?
Yeah.
Minus this number.
So I
And then
just
you will have your C.
do 105 minus the borrowing
So
with
this
the
number
interest.
plus this number minus this number. That's how you get your C1, right?
Yeah.
What did you get?
That's one side. That's 94.5.
94.5. Is it clear for everyone how we got to 94.5? So you can just ask if anyone has a question, how do you get that blue number? Just let me know, then I can tell you. Okay. So shall we have a look at the statements then if there are no questions about this so far? Okay. Which statement is correct? So C and D are saying that the interest rate is 2%, while we already know it's 5%. So we know that those two are not correct. Then which one is true?
A.
Yes, very good. And that's the action question. Perfect, guys. Thank you, Timmy. Okay. Then my question is, how do you guys like this method? Do you guys like it? Any feedback so far? Good. Okay. Then my question was, do you guys have a particular question that you find really difficult, you were not able to figure it out, and that we can now try it with the new method we learned? Did you guys have a particular question that you found difficult? Maybe from the quiz, maybe from the workbook, it doesn't matter. Do you have something? Because it's good to now go back to some questions you first found difficult. And maybe if you try it now, you think, oh man, that's actually really easy. I see something in the chat. Do I have the quiz questions? No, I don't have them, but maybe you can still see them, and then maybe you can make a screenshot. Can you still see the quiz questions? You found the material of the last quiz pretty difficult. And I think you're now at a quiz about week 2, right? And we are now doing week 1 in the trial session. Yes. Yeah, so that I cannot discuss the quiz questions of week 2 yet. Maybe after the session, but I will not record it then. So, but nobody had any questions about week 1? No? Okay. By the way, we scheduled the sessions in such a way that they will also prepare you for the quiz questions. So you will see that each session that you will have in the weekly course helps you to be prepared for the quiz question. So, but not for week 1 and 2, obviously, because those are already have passed. But okay. No questions? Okay, then my question to you guys is, if you don't have any questions you found difficult, do you still want to do some more action questions about the Hirshleifer model? Or do you say, well, I actually get the method, I know how to do it, I'm fine? Or do you still want to do one more? Then I get an odd action question or something. You can vote in the chat if you want to practice one more, or if you say it's okay. Okay. You guys say, let's do a break, and then I will move to chapter 2, the other topic. That's fine. Let's have a break. And then after the break, we move to chapter 2. So I might finish a bit earlier today. We will see. Okay. So break. Shall we continue at 35? All right. See you then, guys. Okay. I hope you guys enjoyed the break. Maybe you can send me something in the chat if you are back. Maybe you can just say yes if you're back. So Timmy is back. I see a thumbs up from AO. Lieslot is back. Okay. So what we're going to do then is we're going to move to chapter 2. But you will see that chapter 2 is actually not that much. So we will do that. And then afterwards, we will practice some old axiom questions. Then we're basically done with week 1. And I saw that you guys maybe had some difficulties with some other week. Then I will just hang around to help you guys with that as well. You could just ask your questions and then I will help you with your questions. But that part will not be recorded. So I think that's how we will schedule it. Okay, let's start. So here you have some basic concept in finance. And that's the market maker, also the liquidity provider. The idea is basically as follows. If you are the owner of a stock and you want to sell that stock, let's say stock Apple. What would be really inconvenient is that you have to look for another person that wants to buy that stock from you if you want to sell that directly, right? Then it takes a long time before you meet that person that also wants to sell it, that wants to buy it from you. So the idea is that there's a market maker and he will make sure that you can buy or sell your stock instantly. You don't have to wait before you get matched to someone. The market maker makes sure that you can buy or sell your stock instantly, directly. The only thing is that the market maker wants to make a profit by doing that, and that will be the bid-ask spread. The idea is that if you want to sell the share, the market maker will buy it from you, but he will ask you a very low price, a lower price than normally. So let's call it the P bid. So let's say that the P bid is, for example, 98 euro or something. So if you sell it, you only get 98 euro. But you also have the ask price, and that's when you want to sell the share, how much will the market maker pay you? And that's the P ask. So sorry, I don't think I said it correctly. So let me say it over again. The bid price is the price you get when you sell it to the market maker. And that's a very low price, 98. If you want to buy it from the market maker, you have to pay a really high price. For example, 102. That will be the high price. And the difference between the bid and the ask price, that will be the spread. And that will be 4 euro in this case. And that's the idea here. Okay, so basically, if you buy it from the market maker, you pay 102 euro. If you sell it to the market maker, you only get 98 euro. So you already lost 4 euro there. And that's the idea, that's the compensation for the market maker. And then here I set a reminder, the ask price is always higher than the bid price. So that's also how you can remember that. So the good thing is that you can buy or sell your shares instantly. The bad thing about this is that the market maker basically earns some money on this, while the actual price might be 100 euro. If you buy it, you pay a bit too much. And if you sell it, you receive a bit too little. So that's the idea here. So it's really easy, this part. Maybe Timmy, could you make a picture of question 2.1 and 2.2 and send it in a WhatsApp group.
Sure, one sec.
Okay, so here I summarized it. Let's have a look. Yusri, are you already there? Or are you still not able to say something? Then I will ask Wiskunde Maniac. Could you help me with this question? Or are you also not able to chat? Neil, maybe? Do you want to help me? With question 2.1. Okay, then I will ask Lieselot. Would you like to help me?
Yes, of course.
So I want to buy a share. Do I have to pay the bid price or the ask price if I want to buy something?
The ask price.
Yes, the high price, right?
Mhm.
And then on November the 19th. So which of the numbers do you have to choose?
The 52 euros.
Yes. So the ask price on November 19th. So that's 52 euros.
Mhm.
And then I buy 100 shares. So what do I have to pay for it?
5,200 euros.
Yes. Do you also want to do 2.2?
Of course.
If I sell, do I receive the bid price or the ask price?
You received the bid price.
Yes. And then from the 12th.
So then it's 50 euros and 40 cents per share.
Yes.
I think it's 200 now. But
Oh, sorry. There in the question they say 200 indeed. 200. I sell 200 shares, and then I receive the bid price if I sell, and that's given in this note. And then I think the answer is already in the workbook.
Mhm.
So it's is it like this?
It's 10,080. So another zero.
That's 80. Yeah, sorry. Okay, perfect. Is this clear for everyone? So you just have to know definition of the bid price and the sell and the ask price and the bid ask spread, which is the difference between those two. Okay. So you will see that chapter 2 is really easy. It's just memorization. Okay, so what you have here is you have all the formulas about chapter 2. So I will make a screenshot of this. And what you will see is that you just learn the formulas and then you can use them to to make the questions. And it's really just memorization. Here, it's not that difficult. So you, for example, have a formula from net working capital. That's the total current assets minus the total current liabilities. Market to book ratio. That's the market value of the equity divided by the book value of equity. And then how do you calculate the market value of equity? Well, first of all, the market value of equity is a different name for the same thing, namely market capitalization. So market value of equity, market capitalization is the same. And you calculate it by multiplying the amount of shares with the price per share. So amount of shares outstanding times the price per share. Well, then you have the formula for the enterprise value, the current ratio, and the quick ratio. It's basically just remembering those formulas and then filling them in. Okay. So let's do some exam questions. Deal? Were you able to talk? I don't think so, right? So then I would just ask Eo. Eo, would you like to help me?
Yeah.
So I sent you a picture with all the formulas, right?
Yeah.
So you can now see the formula of the quick ratio. That's what they want to know here.
It's total
I will call-
current assets.
Sorry?
Yeah, it's total current assets.
Yes. And what is the total current assets in 2016?
This one, 2050.
Yes. So I don't write down the formula, but it is in the WhatsApp group, right? And on the previous slide.
Now we need to deduct
Minus,
the inventory.
which is 800, right?
Yeah.
Divided by,
Total current liabilities, which is 1770.
yes.
And the result is 0.71.
Yes, very good. That's easy, right? It's just, yeah, basically memorizing the formulas and filling them in. Okay. Thank you. Any questions about this? I think this chapter is pretty easy, right? Okay. Here's another one. Lieselot, would you like to help me with this one?
Yes.
Here, they want to know the following thing that's on the next slide. Maybe I can better share it in the WhatsApp group. So you can now see the full question. But what we want to know is, what is the enterprise value? My first question is, what is the formula for the enterprise value?
That is market value of equity plus debt
Yes.
minus.
Equity plus debt minus the cash, right?
Yes.
Perfect. And how can we calculate the market value of the equity?
Even assets is liability and equity, and I think you have.
It's the so according to the formula, it's the number of shares outstanding. If I look in the summary, times the price per share, right?
Yeah.
What you will see is that in this type of questions on the exam, they give you a lot of information that you don't need. So we will just read through the question, and you can tell for which variable you need the information or not. So we have 40 million shares outstanding. Do we need that?
Yes.
Yeah, so I will fill in 14 million. And the price is 25 per share. Do we need that?
Yes. As well.
Perfect. Then what is the value of the equity?
350 million.
350 million. And now I can fill it in here, right?
Mhm.
So now I don't net the market value of the equity is 350 million. At that day, cash equals 20 million. Do we need that?
Yes, we need for the minus cash.
Yes. Accounts receivable equals 14 million. Do we need that?
No, I don't believe so.
No. Accounts payable,
No,
60 million inventory.
no, we don't need that as well.
Book value of non-current assets.
No,
And then the market value of that.
yes, that one we need.
Yes. Great. Then we have everything we need for the enterprise value. So now you can fill it in.
So it must be 380 million.
It's 380 million. Okay, let's have a look. That's the correct answer. So I will give you some time to copy it. So in my opinion, this is the most easy chapter because it's just memorizing formulas, which is, in my opinion, also pretty difficult. And then you fill in the formulas. So it's not difficult, but it's a lot of work that you have to put in to remember all the formulas. But if you put in the work, nothing can go wrong. You will definitely pass it. Okay. And that's it. That's basically all the material I want to show you today. So I have one more exercise here. Maybe that's also fun to show you. It's about this formula. If everybody wrote it down, and always tell me if I go too fast. But okay. So one last formula here is about the following, and I will introduce it so that you don't even have to remember the formula, but that you just understand it. Okay, let's say that the annual interest rate is 100%. That's a lot, right? So if you put 100 euro on the bank, next year you have 200 euro, you double your money. Okay. N will be the amount of interest payments in a year. So here I assume that I only pay the interest once. How it then looks like is as follows. Here you have T0 and here you have T1. Let's say that I start with 1 euro. That means that I will get 100% for this whole year. So with how much money do I end up? Does anyone know? It's really easy. You just end up with €2, right? If the interest rate is 100%. That's situation one. Same question, but now I will change the n and I want to show you what happens. The annual percentage rate still 100%, so you basically get 100% interest. But the n is now 2. What does that mean? You will now get the interest paid out twice a year instead of 1 time a year. You will see that if you are saving, this will be very favorable to you. You will get a higher effective rate, you will see. So let me show you. T0, a half. T is 1. And I again start with €1. So the idea here is that you now will not get 100% once, but you will get the 50%, which is half of the 100%, twice. So you get 2 times 50% interest instead of 1 times 100%. And what you will see is that this is more favorable because now the interest can compound a bit more. So you will get, let me use some other color. You will get 50% for the first year, and then for the first half a year, and 50% for the second. So what you get each year is the APR divided by n. Each period you get APR divided by n. So then I will ask Timmy. I start with €1. Then after half a year, how much euro do I have?
150.
Yeah, 150. And now the interesting thing, now I get 50% over that 150. How much do I get? How much do I end up with? So 150 times 1.5.
175. No.
200. So 150 times 1.5. Can somebody help her else? Oh, you know it? Yeah, €2.25. That's really interesting because here you only got 100% divided by 1 is 100%. And then you ended up with €2. But now you got the interest paid out twice a year. And then you get some extra compounding. So you get 50%. And on top of that amount, you get again 50%. So here your effective interest rate, your effective annual rate was 125%. Do you see that? Well, here your effective annual rate was just 100% equal to your APR. Let me do another example. APR is 100%. And now the N is 4. So the interest rate will be paid out quarterly. End of first quarter, end of second quarter, end of third quarter, end of fourth quarter. Okay. So we start again. T is 0, T is 0.25, T is a half, T is 0.75, T is 1. And I again start with €1. My question to you is, Eyal, how much percent interest do I get each period, each quarter, if I pay it out 4 times a year?
25%.
Yes, you get 25% on each period. The question is, with how much do I end up? And to do that, you do your starting value, which is 1, times 1.25 with the power of 4. Do you agree with that? €1 times 1.25 with the power of 4.
Yeah. The answer?
Yes, but what do you get?
2.44.
Yes. So what you see is that the higher the N, the higher the effective annual rate will be. So you get a higher percentage, because what is here the effective annual rate? So first it was 100%, then 125%. What is here the effective annual rate?
Oh, 144.
Yes, 144%. So what I mean with this is that the higher your N is, so N was the amount of interest payments per year, the higher the N is, the more it will compound, and therefore the higher the effective annual rate is. So you actually get 100%, but in reality you actually get 144% because you have some extra compounding because the N is bigger than 1. That's the idea here. Okay. Now the formulas. The formula for the effective annual rate is 1 plus the APR divided by n with the power of n minus 1. So you can try it out. You can, for example, try out filling in one of those numbers, for example, those, and then you should get 144%. And notice that if you have an APR of 10%, you fill in the formula like 0.10. If you have 5%, you fill it in like 0.05. You know that, right? So if the APR is 100%, you fill it in as a simple 1. So maybe you want to try it out. 1 plus 1 divided by 4 with the power of 4 minus 1. That should give you the 144% if you multiply by 100%. Does the formula work if you try it out? Okay. Then, here you also see the formula. Here are some examples. Timmy, could you maybe send a picture in the WhatsApp group about question 2.80? So 2.80. Really? Let's do 2.18 on the whiteboard. Lieselot, would you like to help me with 2.18?
Yes, but I do not completely get it yet.
Do you want to try it?
Yes, of
So
course.
what is the formula for the effective annual rate?
It was, let me look back. It is
1 plus?
1 plus 100 divided by 2.
No, that one in more general form, it's the
Oh.
1 plus the APR.
Yeah, divided by n. I'm sorry.
Yeah, exactly. With the power of n.
Minus 1.
Yes. Okay. What is the APR in question 2.18?
5%.
Yes, it's 5%. So we filled in as a 5 or like a 0.05?
0.05.
Yes. And what is the n? Notice that they say
Daily.
it's compounded daily. So how many days do you have in a year?
365.
Yes. Yeah, we have everything. So do you understand what the APR, the N, and the effective annual rate are?
Not really.
Okay. So maybe I can go back. The APR is the stated interest rate that they will tell you. This was the interest rate is 100%. But then you also have to read how many times it will get paid out in reality if you bring your money to the bank, because the APR is not what you in reality get. It's influenced by how many times per year the interest gets paid out, because the more times it gets paid out, the better for you as a saver. Okay. So N is the number of times the interest is paid out. Do you only pay out 1 times 100%, or for example, 2 times 50%? Then you will see that the 2 times 50% is better, because then you have more compounding. Then you end up with 225 instead of 2. Do you see that?
Yeah, I get it now.
And then the effective annual rate is how much percent you actually have gotten. If the n would be 1, what then would be the APR to end up with that amount? That's
Oh.
basically what effective annual rate is.
Yes, okay. That's
So
clear.
in the 3 boxes, I did it intuitively, but you can also just remember this formula here.
Okay.
Okay, now you can plug this into your calculator and then you multiply it with 100%.
Mhm.
And what do you get?
Rounded up, it's 5.13.
5.13. All right. Did the rest also get that? Does it make sense that it is above the 5%? Yes, right. Okay. Then that's the last question from this trial session. Then I will just hang by to help you guys with some other problems that you have. But this was the last material. I will just stay around to answer some of your questions. So I will stop the recording.